Hi all, this is my attempt to explain BItVM, full program logic verifiable on the Bitcoin blockchain, new development. If you look at Bitcoin, it's quite a simple protocol. It moves funds from one to another, and it's all done by signatures, and everything is registered on the Bitcoin blockchain. So Alice can move her ownership of funds to Bob. In 2022, we started with Taproot, which includes a little more complicated signatures, so you can combine signatures together, and that creates some opportunities of one BItVM takes advantage of. So just look where we are with Bitcoin. It's super stable, fully decentralized, super secure. It's a store of value where there's a fixed amount of coins, where new parts are being added through proof of work, with growing hash rate, so the security is increasing, and we now have Taproot consensus. The drawbacks are a bit that we don't have the opportunity to include smart contracts because there are limitations to what we can do with the protocol. We have some issues with privacy, and we have some challenges on transaction speeds, and that's why a lot of altcoins have started. So what is the opportunity that BItVM gives us? It's an opportunity where we can start to create real programs, real logic on the Bitcoin blockchain. We call that Turing complete, so we can do anything that a program can do in normal life, we can also do on top of the Bitcoin blockchain. There are no changes to the protocol, so we don't need a soft fork or even a hard fork, of course. So it can all be done using the same opcodes as we use today. And what we create is a simulation of a regular computer in Bitcoin opcodes. And the programs can run off-chain, and that's the biggest or the real approach. So programs can run off-chain, and when there's a debate, we can use the Bitcoin blockchain to verify those programs. So just look at a computer compared to BItVM. A computer just works with electronic signals that are on or off, and we can put some logic in. So we can create very complex logical circuits. And we do a similar thing with signatures. So we start using the on and off by setting a signature to a transaction. And we can create the same logic through opcodes. So we can add, subtract, multiply, etc. So a set of instructions that is created using the opcodes of the Bitcoin blockchain. Just look at a basic thing of a computer. It's a 0 or 1, and it has instructions. If we look at the computer, we have bits on and off. If we look at Bitcoin, we have signed or non-signed transactions. And we use logical circuits in a computer, and we simulate those logical circuits in Bitcoin using those opcodes. How do we implement? At the lowest level, we create Bitcoin through Bitcoin opcodes a RISC-like instruction set. And a RISC instruction set is a kind of baseline instruction set that is used in multiple computers, and a lot of programming languages are able to generate code that runs on a RISC chipset. We simulate that chipset using Taproot and signatures and opcodes in the Bitcoin blockchain, as you can see here on top. So it can run on the Bitcoin blockchain, but of course that is very expensive, because if we run the full program using transactions, that will be far too expensive in transaction code. And we use the Bitcoin blockchain where it's not intended to be used for. So what we do is we run a similar program, so we create a kind of a copy, And the BItVM can also run outside of the Bitcoin blockchain. So we can run it on any computer, like you see here on the low level of the slide. So we use a kind of an optimistic roll-up, you could call it. Yeah, we assume that everything goes fine and that Paul as a prover and Vera as a verifier run program logic, and if they run it on their own environment, and if they agree, nothing happens. So they run the BItVM instance, they run the BItVM compatible program, and in the end they agree normally. What do we also do? We can we create with every step of the program a stage situation is saved. So at the start, Paul and Vera run the program. We start with the signatures. This is what we're going to do. We start the values and we use the program as we intended to do. And with every execution, the state of the machine is saved. We're doing it multiple times, so 1, 2, etc., up to n, and then we end with the result. And if we agree, everything is fine. No need for the Bitcoin blockchain to start to work. But what if Paul cheated? If Paul cheated, we just look at all the different stages with all the signatures and the program. And Vera just runs a binary search where she says, hey, this is the place where I think Paul has cheated. So I can look back, and at that time I run that small part of the code on the Bitcoin blockchain. And when that is fine, we agree that the protocol sees that Paul has cheated, and the cheating is proved, so the funds are moved to Alice. So where are we at the moment? If you look at the 2023 BItVM, and it's rather new, we use the ones and the zeros for signed or not signed, machine code with opcodes, and at the moment we have a BItVM machine, which is quite an impressive machine already. You see here a kind of a simulation, a lot of programs we can run on this machine. There are a couple of instructions that still need to be added to make it fully compatible, but it's working in a very fast. The development is going very fast, and the intention was to create it at the end of the year, so we're almost there. So that's where we are at the moment. So what is the development that we're seeing? Everything is open source, so we can use and reuse, and a lot of people are building on it. And since we're using a RISC chipset, RISC-based computing, a lot of the programs that we already are available, we can run on that same chipset. So the reuse of that environment will give a lot of speed to the development. So you can look at things like smart contracts that we have on Ethereum, Solana, etc. You could look at adding more privacy, like we have with Monero and Zcash, or you could look at improving the transaction speed. A lot of opportunities that we can just align the Bitcoin blockchain and put a little bit more logic on top of it. So in the end, we'll still use the Bitcoin as the store of value and as a medium of exchange for all kinds of things that we're doing in the blockchain space without creating additional coins. For example, if we look at smart contracts, if you look at Ethereum or Solana, you see that they're running complex code on the blockchain. Yeah? While Bitcoin is fully decentralized, the computing will be off-chain and gas prices will not be there. We see on the other hand a more centralization in Solana and Ethereum. We need an additional contract, so that's the approach we can use for smart contracts. The other one is if we look at privacy. Yeah, the Bitcoin blockchain, of course, we know is an open blockchain. It has private keys to get to the blockchain, but of course we have know your customer pressure. And there are good developments with Monero and Zcash, for example, and we can just use that open source code to add that to the Bitcoin blockchain. And with that we can also limit the issues of an additional token that we have with those privacy coins, and the auditability, which is always a problem when there's full privacy. The auditability is one of the backdoors, of course. The other thing we can probably improve is the layer 2 solutions that we have, like on the right side, Lightning, the liquid RGB ARC. That is one of the options to increase the speed of transactions. So we can also order a cup of coffee and pay in Bitcoin. We know that Bitcoin is fully decentralized, and that's why we only can get to 7 transactions a second, because all the nodes need to be synced. And at the moment also the transaction costs are increasing, which is a good thing, by the way. But with the addition of the layer 2s, we can solve that problem, but there's still a lot of work to do in that area. And by creating small programs that can interact and verify things on the blockchain, we can probably also improve parts of those protocols and limit the centralization that we have with the other with the layer 2s. So as a recap, we just continue to use Bitcoin as the store of value, fully decentralized, and the proof of work that we have. It opens the Bitcoin blockchain for Turing complete code. We can run elsewhere and do just a verification on the Bitcoin blockchain, so we're not spoiling the Bitcoin blockchain with unneeded transactions. It opens up to possibilities that are implemented in other chains, and we can use best practice code, etc., for privacy, speed, payments, etc. And the big advantage: no other coins needed. We just use the Bitcoin blockchain, and that's the medium of exchange. So I hope you liked the video. It was just my attempt to explain something that I believe is very interesting. Any comments, please leave a note. Thanks.